All right, so let's talk some more about measuring arcs and angles. Okay, we're going to have a few things that we're going to see that are, again, we're going to see another kind of arc that we want to talk about. The first thing, let's remember some important concepts here. Our arc is going to be a part of the circumference of the circle, so just a little chunk of all the way around. Your central angle is one where the vertex is going to be at the center, hence the word central angle. And these sides are the radii, plural for radius, of the circle. We have our minor arc that we talked about in the first set of notes, that is going to be one that is measured less than 180 degrees, and it's named by its endpoints. We have our major arc, which is the measure that, which is going to be an arc that has a measure of more than 180 degrees, and it's named by the endpoints and one other point. Now, your notes do not have congruent arcs, and your notes do not have, or your notes do have this last part. So I want you to make sure that, so just ignore the fact that I have congruent arcs on there. We will not be talking about congruent arcs. But we need to remember here, another thing we learned is arcs are measured by their corresponding or matching central angles. Okay? So here, the measure of your central angle and the measure of your arc are going to be exactly the same. So we're going to go ahead and name the following on these guys here. We want to know the central angle. Well, the central angle's vertex is right here at the center. So your central angle we can list as angle LEY. Now, that could be the smaller angle or the bigger angle, just depending on which arc we're looking at. If we're looking for the minor arc or the major arc. So your minor arc, remember, less than 180, named with just its two endpoints. So we have here arc LY. Put that arc above it. Your major arc is going to be on the other side, and we have to use its endpoints, and we have to pick up that letter. We have to pick up another point on the way, so we name it arc LUY, or you can name it arc YUL as well, whichever way you decide, whichever direction you go on that one. So arc LUY. Now, example number 2, I was just realizing, is exactly like what we did on the first set of notes here. Let's go ahead and talk about this. Again, remind ourselves, because we're going to be dealing a lot with central angles here. We are going to find the measure of each. We want the measure of angle PCM. Okay? Well, they gave it to us right here. The angle measurement is 110 degrees. We want the measure of arc PM. Well, the measure of arc PM, okay, is going to be equal to the central angle, the measure of angle PCM. Okay? We have the same, they're going to be exactly the same, so that means this is also going to be 110. Then we want the measure of angle PNM, and what we did as a reminder is here we need to take all the way around, because we know right here this is 110 degrees. Well, we want to know now what the major arc is going to be. Well, both of them together are going to be 360 degrees. So we subtract that 110, and we're going to get 250 degrees. So this is our answer here. The last is what kind of arc is PM, and how do you know? Arc PM we know is a minor arc. We know because, number 1, less than 180 degrees, and named with W/ with 2 letters. So now let's pause and get caught up. We're going to go ahead and go on to the next part. We're going to talk about the next kind of arc, which is going to be your semicircle. Your semicircle is going to be an arc of a measure of exactly 180 degrees. It is exactly halfway around the circle. It is formed by diameters, okay, because the diameter cuts that circle straight in half. It's going to be named by its endpoints and another point on the arc. So just like a major arc, the major arcs and semicircles have to be named with those 3 different letters. Okay, so this is going to be noted. We have 3 letters. Just like a major arc. So anything 180 over, we're naming with 3 letters. So let's go ahead and take a look at what we have here in this diagram. In circle E, we have the measure of angle AEN. So from A to E to N, right here is 18 degrees. JN is going to be our diameter. Okay, so JN, segment JN is a diameter. It is cutting the circle into two congruent parts. The top that we have on this one and the bottom. Okay, cut it directly in half. And then we're also told that the measure of angle J to E to S is going to be 90 degrees. Let's find each measure. First, I want to find arc AN. Well, arc AN is right here, and we already explained that if we want the measure of that arc, it's going to be the exact same as its central angle. In this case, we just have 18, so it's just flat out 18 degrees. Okay? Now I want to take a look at arc JA. So we have here from J to A. Well, I know that JN was a diameter. Okay, let's actually highlight that real quick. So we have JN is the diameter. So that means from this whole upper part is going to be 180 degrees. So that 18 plus whatever this other arc is, JA, is going to equal to 180. So if we just take a look at that top half here, we have 180 degrees. We need to get rid of the 18 to see what's left over for arc JA. So we take the 180, we subtract that 18, we should come up with 162 degrees. Now we are going to find, let me trace this with my other color too, that color I used, the corresponding color. Okay. Now we're going to find the measure of arc JAS. So we need to go from J past A all the way over to S. And what we need to see here is all the way around is 360 degrees we've talked about. Well, arc JAS includes everything except for arc JS. And because the central angle JES is 90 degrees, the arc JS right here is also 90 degrees. So we just need to take the 360 all the way around, okay, and pay attention to what I'm doing real quick. If we go all the way around, it's 360. Well, let's take away that 90 degrees to figure out what's left for arc JAS. So all this is 360, subtract the 90, and we're going to wind up with 270 degrees. Central angle is all about either being congruent or the 360 degrees all the way around. Here we are going to use this diagram to solve all of these. Okay, we are going to need a little bit of room on here. I'm going to go ahead and warn you that now. To find each one of these angles, we have to have x so we can substitute in for x. While using this all the way around is 360 degrees, we're just going to go ahead and take each one of these and add them to equal 360 degrees. So I'm going to take that 3x plus 15. I'm going to add the x. Moving on, I got my 4x, so add 4x plus that last one of 2x plus 15. All equal to 360. It's a lot of stuff to add together. We have to look at our like terms now. Here I have 3x. I have another plus x here. I have a plus 4x and a plus 2x. So all of these combined together, 3 plus 1 is going to give me 4, plus another 4 will give me 8, plus the other 2. I've got a total of 10x. And I take a look at my constants. A lot of stuff to combine. That's why I didn't pause it for you to work on your own. We have a positive 15 and a positive 15 is my constants. That's it. So we end up with a positive 30. All set equal to 360 degrees. So very quickly, pause it so you can get it done on your own. We'll subtract that 30. 10x is going to be equal to 330. When we divide both sides by that 10, x is going to come out to equal 33. Okay, so we're going to have to use that bit of information to find everything else. Okay, so all of this so that we can find all of our different angle measurements. So here we want the measure of angle the angle AOB, so we go A to O to B. So we're looking for this angle right here. Oops, that was my wrong orange. Sorry about that. I don't know why it matters. So we're looking for this angle right here, remembering your central angle is the exact same as the arc, its corresponding arc. And X was simply 33 degrees, so this is just 33 degrees. When we take a look at angle BOC, so let's go from B to the central angle. This is going to be our central angle here, BOC. We want 4x. So to find that, we just simply need to plug in 33 for x. 4 times 33 is going to give us 132. So here's 132 degrees. Next, we're going to find the measure of angle COD. So COD, and we're going to use the arc here. So we're going to substitute in. We're going to have 2 substitute in 33 for x plus your 15. Okay, your 2 times 33 is going to give you 66 plus 15, and that's going to give you 81. So we have 81 degrees. The last angle we're going to look at is angle AOD. Okay, so this last angle, last central angle, and the arc that corresponds with it. So again, just we have x, so substitute, take x out and substitute in. So our 3 times 33 gives us 99. We add that to the 15, and this is going to end up being 114 degrees. And then check. These are all 4 of the central angles. Add all 4 together, you're going to get 360, so you know you're good. So let's do a little bit more work here. Last problems, last example here. We're going to use a segment PZ is going to be a diameter. So PZ right here is going to cut that circle in half, where we're going to have 180 degrees on one side and 180 degrees on the other. So we're going to find each, and we're going to classify. We're going to not only find the measurement, but classify each one. So the first one here is going to be arc PN. So here we're looking at arc PN. Okay. And again, now we're going the opposite direction. Earlier I wanted the angle and we have the arcs. Now we have the arcs, we want the angle. Exactly the same. So here I see a 90-degree measurement, which means that my central angle is 90, so is the arc. So this is 90 degrees. And we look at the size of it, we look at the number, and we can tell what kind of arc, major, minor, or semicircle. This is going to end up being a minor arc. Next, we're going to look at measurement of arc ZQP. So we're going to go from Z over to Q over to P. So we're going to see what we're tracing here. What we have done is we have gone from one part of the diameter all the way around to the other endpoint of the diameter. We have covered half of this circle. So this is our 180 degrees. Actually, I'm not going to write it there just yet. So this is 180 degrees. And major, minor, or semicircle, well, it's got 3 letters, so it has to be either major or semicircle. We look at the measurement, it's exactly 180 degrees. That is our semicircle, or semicircle. Now let's take a look at arc RZ. So looking right here at arc RZ, okay, well, what we do know is that we have half the circle right here that when we just found ZQP was 180, and I have 38 and 87. Well, if I take the whole arc, whole semicircle, that 180, I take away that 38, and I take away that 87, we're going to find out, subtracting both of these arcs, the 2 of the 3 arcs that we have, it's going to end up equaling 55 degrees. So this part right here will be 55 degrees. It is named with 2 letters, so we automatically know it's a minor arc. Also, the measurement is 55. So here we have another minor arc. Next, we have arc with the measure of arc ZMP. So we're looking at Z go through M to get around to P. Okay? So again, we've gone from one point of the diameter all the way to the other point of the diameter, meaning we have hit that 180 degrees semicircle. So 3 letters and exactly 180 degrees, we have another semicircle. Lastly, we are going to look at arc, RM. So we're going from R to M. We want the shorter route, so we're just going R over to M. Okay? So with this one, what we need to figure out is what ZN is, so that we can, well, actually, the easiest route here is, look, guys, we know what all of these angles are. Okay? We know all of our central angles, 55, 87, 38, 90, and 25. Well, all the central angles together is that magic number 360. So let's add up what we have and subtract it from that 360. So we're going to take that 55 plus the 87 plus the 38 plus that 90 plus that 25. Adding all these together, you can put all the plus signs if you want to. When we add all of this together, we are going to get 240. So that's everything except what we want. So everything is 360, but we need to subtract that 240 to see what's left over for what we actually want. And this ends up being 120 degrees. So we have 120 degrees here. We notice it is named with 2 letters, and it is also under 180, so we have yet another minor arc. We didn't deal with any major arcs in this problem, or in these notes, okay, or not on this section. So there's more on your central angles and your arcs, remembering that central angle and its corresponding arc are exactly the same. All the way around is 360. Your diameter will create 2 semicircles that are 180 degrees each. We just label everything as we get it so that we can find what we need. Hopefully this helped out.